I'm relational database. I store my data in tables. I like everything to be kind of as it is, highly normalized. I show cardinality, and I've been around since 1970s. Everyone loves me, and I'm by far the most popular database.
Hi, I'm no-SQL database. I'm different from relational database because I don't use tables, but I use other methods of storing and retrieval. I cope with greater processing needs, and I can deal with things that relational databases cannot, such as scale, agility, and I can make use of cheap storage. I can also cope with large amounts of structured, semi-structured, and unstructured data.
I am, as you can see, object-oriented database. Now what makes me great is I am a subdivision of a non-SQL database, but I've kind of sorted out quite a lot of the kinks, and there's actually ways to search properly, and like I've gained a lot of popularity, mainly because like I can store complex data instead of just strings, bits, and those type of things. Those boring things. I can store movies, pictures, and all sorts of creative things. That's what makes me great.
What's up? I'm DW Data Warehouse. I'm very different from these guys because these guys are more operational databases. So what I do, basically, I just store data. It's like non-volatile type of thing. The data just comes in. It can be accessed. It's more like a decision-making database where executives of an organization sort of look through past data. Things that have happened, if they want to analyze, see trends and patterns, they look into what I do. Like, I'm the man. These guys need me.
My main argument with you is, like, we've all developed a relational database and drawn the model and everything, and it's such a headache because you have to make sure that, okay, the volume of this needs to be in a separate table and then this, and it's just confusing. Like, why can't you just make an object? This is a glass. It is a glass. It has characteristics. It has methods. And it's its own little unit. And then you can say a water is a related object to this. And it's just simple semantics, which are nice.
Well, although it may be initially quite difficult to set up with the structure, once it's all set up, it's very easy to understand. It's very user-friendly. Everybody knows how to operate me, how to write simple SQL statements to access data and to produce reports. It works with stuff like Microsoft Access, which a lot of businesses use. The main issue is that once it's set up, it's a lot easier to understand and to operate on.
That's a fair point, but you know, humans are yesterday and computers are tomorrow. So computers understand structured languages like, structured pages like XML, and also the structure of it is very similar to object-oriented programming, which is basically the most popular programming languages out there, like Java, C, and C++. Artificial intelligence, which really helps for analysis and things, is very effective at reading object-oriented databases.
Okay, although, yes, computers are the future, you still need people to operate these computers, and not everybody is going to have a degree in programming where they know all these different languages and use that to search through the database and perform operations. Whereas relational databases, all you need to know is the SQL language. SQL is easy to understand. A lot of people already know how to do it, and you don't need an extensive background in computer programming to be able to use this language to perform operations on the database and extract information that you want. And yes, tables are easily understood by humans, and we are humans and we are the ones that are going to be using this data, so might as well have it in a format that we understand.
One advantage about no-SQL databases is that we can add attributes to objects on the fly without having to change the whole structure of our database.
Well, so can I. I can also add new columns, new attributes to my database.
But you would have to add the column and then migrate your whole database, which would cause downtime, and downtime is not necessarily a good thing.
And another amazing thing about object-oriented databases is you can use inheritance, which is basically the most powerful thing within object-oriented databases and object-oriented programming. Because instead of redeveloping, let's say we have a person object, and then this person object is a student, and that one is, I don't know, a government worker, and da-da-da-da. So instead of having to create a separate table for each type, we just create a single one that is a person object, and from that we inherit the name, surname, ID number, date of birth into a student object, which also has extended the student number, the degree, the university, the year of enrollment. So you can add a lot more extendable things, but in a structured way. And also what's nice is, say now a person has some methods. These methods will also be inherited by its children. So all these children will have what the parent has, but it can extend into more functionalities. And that also leads to another important thing about this, is you can actually implement methods within the objects, which is something you can't do with that.
Okay, so I hear you guys now. You're talking and it's nice time for you guys. But where I come in is where I'm different. I'm not part of the operational database. So the reason for that is because you guys constantly have to update your systems and you're working on a day-to-day basis, whereas I have to just collect everything. I don't update as frequently as you guys and stuff like that. Also, you guys are optimized for well-known tasks, day-to-day operations, whereas I'm optimized just to sort of bring everyone together because I'm separated into 4 parts: subject-orientated, integration, time-variant, and non-volatile. So basically, with integration, I bring different sources of information or data from your relational databases and file systems or whatever, and sort of bring it all together, not necessarily in a certain format or structure, but it can be accessed when things like OLAP are used to process data and analyze data. So the integration process is very important because it needs to be analyzed effectively so that the information can be used by executives in the company when they make decisions, strategic planning, and stuff like that. So these guys, they can have their argument in their fun times, but they need to come back to me, and I have to sort of process what they've been saying, make sense of it, such that the business can go and can make money, not what they do.
So you're basically saying that we're sitting with how to optimize the data, but you're actually looking at how to optimize the business.
Exactly.
Okay, but one of the major benefits about me is that I have a great security system. I can move separate attributes, sensitive attributes that perhaps a business doesn't want just anybody knowing. I can move those attributes to a separate relation, and that relation will have its own authorization control. So that specifies who can have access to that, and with the right access you can then move it back to the original relation as well to be used with the rest of its data set. What do you do for security?
Well, we can put a field as private, so nothing outside can access it. And then the get function within our object, we can say there's a parameter that needs a specific security clearance. So it'll be a flag that comes through that says 88555, and it recognizes, that is the right clearance, so then it releases that data. So we've got that function at least.
A redeeming feature of no-SQL databases is that we can replicate a whole database automatically without a secondary application or a database management system.
Well, I can do that as well though.
Yes, you can do that, but you need secondary database application management systems to do this for you. We can do it automatically, and we also do it seamlessly, so there's no downtime when this does happen. So in conclusion, I was created in the 2000s to deal with the limitations of relational databases. This deals with scale, replication, and the storage of unstructured data. I can deal with complex data objects and complex structures. I can also process this at a greater rate.
Okay, I mainly use it at the operational level where data constantly needs to be manipulated and updated. So for A point of sale system, very good. I'm the best in the business. One of the drawbacks is that I only store binary information, and my database takes up a lot of space as a result of the large amount of tables and relational data.
I'm quite new to this, but in the programming world, I've been around for decades, and it's a very good system to use due to inheritance and encapsulation. All these features make it a great stable thing, and also the advantages of storing larger and more complex structures. For instance, like when there's many relations, when there's many functions, it just simplifies it by encapsulating it in one single object instead of many tables that are incoherently linked.
Okay, so I'm responsible basically for analysis of the data and the information that is brought out, the way it's represented in a more general form. And I look at trends and patterns that have been sort of happening, and decision making is done after looking into the patterns that have been happening and the data warehouse.